Okay, day one of determinants. Very easy for a 2 by 2. But I will tell you, it does have to be a square matrix to find its determinant. And remember, square means same number of rows as columns. This one here is 2 by 2. The other way they can ask for determinant is to simply put what almost looks like the absolute value signs on it. That means the same thing. That means find the determinant. Again, for a 2 by 2, pretty straightforward. What you do is you take these two numbers right here, you multiply them together, and you write it down. 42. That's what I kind of consider the positive diagonal whenever they go that way. I can kind of consider these other ones the negative diagonal because what you're going to do is subtract whatever it is you happen to get when you multiply them. So when I multiply that, I get a 27, but I'm going to subtract that. Okay? Whatever number you come up with is your determinant. And it is called the determinant because it does determine something. It determines whether that matrix has an inverse. If that number is something other than 0, that matrix has an inverse. So does that particular matrix right there, 7, 9, 3, 6, have an inverse?
Yep.
Yes, it does. I got something other than 0. Okay? So it will, and inverses will prove to be incredibly important. So that's how you do a 2 by 2, pretty straightforward. It's not really all that much work. Okay? But when you get a 3 by 3, you know that has a determinant. Okay? And the easiest way to do that is to get started with your diagonals. So you do this one. The way I say it is that considered a positive diagonal or a negative diagonal. That's considered positive. And so you actually just go ahead and multiply all the numbers together. You just multiply all three of them. So let's face it, it's a negative times a negative times a positive. So the end result's positive here, right? And I'm actually going to put my equals down here because of what I'm going to have to do next. Right? But I've taken a negative times negative, so you told me that's positive. So you take 2 times 3 is, times 4 is 24. Now we start our next positive diagonal and we run out of room. It's like something should be down there. And there's nothing there. And so you kind of consider that it wraps around the matrix and gets the next number, or you could just take this first column and rewrite it. Okay? Because then you can see what it would actually wrap around to. It would wrap around to that -1. Okay? But then you go ahead and you say, all right, well, it's a positive times a positive times a negative. Well, that's negative, right? And so it's a negative. 4 times 2 is 8, times 1 is 8. And that's still a positive diagonal. Then how come I'm subtracting? Because really it's plus a negative, right? Because it's a positive and able to happen to be a negative number when we got done. All right? So 24 minus 8. And if you want, you can just write the plus because we're going to do the last one. Because I got a -1 and I got a 4, and then once again, something's missing. Once again, you got to kind of wrap around the matrix to find out where that goes. Or you could just take the second one and write it again. Because then you got all you need right there. So here I'm taking a negative times a positive times a positive. Well, that is a negative. So again, I could put plus a negative, or I'm just going to go ahead and write minus. And well, what do we get? Well, 1 times 4 is 4, and 4 times 5 is 20. So we went from a 2 by 2 that only had 1 positive diagonal to a 3 by 3 that had 3 positive diagonals. Well, the 2 by 2 had 1 negative, so how many negative is a 3 by 3 going to have? Well, it's going to have 3. And a lot of times what I do is I just go minus. And then it doesn't really matter what order you do them in, you just got to make sure you get them all. So we can start this way. Some people like to work their way back in. They say they worked their way out, now they're going to work their way back in. And so it's minus whatever I happen to get. This is a positive times positive times positive, so that's a positive in the end. 4 times 4 is 16. Does anybody happen to know 16 times 4? 64? Yep. Again, minus. I'm trying to color code it here for you. Whatever I get for the next one, and again, it doesn't matter what order you do them as long as you do them. Now it's minus, but it's a negative times positive, so it's going to be, really this is going to be a negative number, right? So you can either just know and turn that to plus if you want, or write the negative down, because now I can just worry about the numbers. So take 2 times 2, which is 4, times 5, which is 20. And we have one more to take care of. And that's this one right here. Oop, went right into the numbers there. Sorry about that. So it's a negative times a negative times a negative, which is negative. 1 times 3 times 1, well, at least it's a nice number, right? 1 times 3 is 3, times another one is in 3. So you're going to love to have zeros in there. Those are always nice. And now all we have to do is figure out what we've got. Can you agree that this is add the opposite and same thing here? Okay. Now I don't know how you look at numbers, but this is just obvious to me. Why sit there and actually add through all those if those are just going to cancel anyways? And then you go ahead and you add that through, and what do you get? It looks like it's obviously negative because of that 64. Negative 45, is that what you got? Makes sense based on the numbers, yep. Negative 45 is your determinant. So does that monster of a matrix up there have an inverse? Yes, it does. Because what's the one number that's no good? 0. Okay. Because I didn't say anything about negatives. I didn't say they were bad. Okay. So then you might wonder, boy, that's all it does is tells me if I can have an inverse. No, you're going to use that number. It's going to be important. All right. So right now, you know what's coming. Do that one. Let's see if you can do it without me doing it right in front of you. All right, here we go. All right, so if you do this diagonal, what do you get there? 160. Plus the next diagonal, again, you got to take this one over there. Unless you can see it in your head, that's completely up to you. That's an easy one. Negative 63, right? Plus the last one, which means you got to redo that one. Plus 18. Minus. Doesn't matter which order you go. Let's go the other way this time just to prove it to you. Yeah, well, it'd be plus 15. Everybody okay if I put plus 15 or okay? Minus whatever you get here. 112 minus 108. And end result, negative 90 is correct. So, does that 3 by 3 matrix up there have an inverse? Is negative 90 the inverse? No, negative 90 is the determinant. Okay, here we go. As far as by hand, I've yet to decide if we're going to do some of the other ones by hand. Okay, they are incredibly difficult to do by hand once you get to a 3 by 3. Okay, you have to get to what's called row echelon form. I will decide if you need to do that based on behavior. It's not easy. But 2 by 2 you will definitely have to do by hand because there's a nice little pattern you can follow. Basically, if you have this right here as your matrix with A, B, C, and D as your elements, the first thing you have to do is, this just is inverse, that's all that means. You have to define the determinant of A. Well, we've been doing that today so far. In fact, let's face it, the 2 by 2 was really easy. And then all you have to do is you notice that A and D simply change location, correct? This is the nice little pattern. B and C do what? Change signs, yep. So you could say the positive diagonal changed location and the negative diagonal changes signs, right, and the 2 by 2. And that's really all you have to do to find the inverse. We're not really using it for anything yet, but we have to make sure you can find it first. So as it says here, step 1, calculate the determinant. Well, this is pretty straightforward. Well, I could probably do it down here. It doesn't really matter. What, 6 minus a negative 4? Or in other words, 10. So should we even go further? Yeah. We can find an inverse. And what you do is 1 over the determinant, which happens to be, do you see why the determinant cannot be 0? Because it would be 0 on the bottom or in the denominator, which is the one thing undefined in mathematics. Now what we have to do is basically take that positive diagonal, which is the 3 and the 2, and switch their places. So 2 goes here, 3 goes there. And then what we need to do is take the negative diagonal, which are those, and change their signs. So this right here is a positive 1, and this is a negative 4. Now, technically, so if this is matrix A up here, this would be A to the negative 1. Technically, those are inverses. Okay? I am not going to make you multiply that 1/10 in. Okay? But something that's important that I'll make a note of right now is, I'll write it this way. If I take the inverse of A times A, if things are inverses of themselves, they're supposed to do what to each other? Cancel each other out, right? And so, for example, squaring and square rooting kind of cancel out and make themselves go away. Or 3 over 3 cancel out, make themselves go away. So what you get, because really this is a 2 by 2 and a 2 by 2, correct? So can you multiply? So I'm supposed to get a 2 by 2 answer? How does 1 present itself in a matrix? Okay, if they were all 1s, it's not quite right. That is the form of 1 in a matrix. That's called the identity matrix. The positive diagonal will be all 1s. It does have to be square, though. So does a 3 by 3 have an identity matrix? 3 by 3? Sure. What's it look like? Yeah, that's all you got to do. That's basically 1 in matrix form. Okay? And if you think about it, if I were to take this original matrix A times this one here, wouldn't I get the same matrix back? And so that's why it's the form of 1. Okay? You'll need to know that later, but it's a good time to present it now. I'm not going to expect you to do that right now. I'm just showing you that it would happen. So the answer to this question is right there. Here's your inverse. Well, you got to know what's coming next. Do it. As I walked around, it looked very good. What'd you find out for your determinant? I think everybody had it right. Negative 14. Does the negative make a difference? Yeah, it does, actually. All right, now what you got to do, though, don't forget this step. Okay? And then take your negative 1 and your 2 that you've got up there and switch their spots. And take the 4 and the 3, change their signs. There you go. That's the inverse. Okay. Any questions? All right, do I need you to multiply this out? Nope, don't do that. You can if you want, but you don't have to.